Hi, welcome to our 30 to 10 presentation where we'll be talking about the environmental challenges in modern manufacturing. In today's constantly developing world, manufacturing demand is at an all-time high. This has been highlighted by the chip shortage of the past 1.5 years, which has affected products we use on a daily basis. And all of this has been exacerbated by the constant globalization of the world, as well as the constant technological development we see worldwide. And this has caused rocketing demand for high quality goods across the world. However, all of this comes at a cost, a large environmental one in fact, and this is all because unfortunately climate change still does exist. Manufacturing is a major player in this and is a large contributor to greenhouse gases both domestically and globally, with industry contributing to 19% of greenhouse gases in the US and almost 21% across the world.
Environmental issues in manufacturing can be broken down into two main subcategories. I will be discussing the first of these two areas, materials in manufacturing and their disposal. Modern manufacturing makes use of many materials that are either non-biodegradable or non-recyclable. Prime examples of which include plastics, styrofoam, and ceramics. Plastics, which are often utilized due to their lightweight and low cost, are effective at meeting customer requirements and low production costs. In modern times, plastic materials have seen an increase in usage from rapid prototyping and 3D printing. However, the production of such materials requires burning fossil fuels, which contributes to air pollution and climate change. Additionally, post-use, plastics can take anywhere from 450 to 1,000 years to decompose in a landfill. Ceramic materials are also becoming more popular, especially in the automotive industry due to their stability in high heat environments. However, ceramics are also non-recyclable, and their production often releases large amounts of CO2 into the atmosphere. Other environmental concerns with manufacturing materials include the usage and disposal of heavy metals, radioisotopes, and other biohazardous materials. Examples include lead used in lead-acid batteries and toxic lithium compounds used in lithium-ion batteries, which are becoming increasingly common in the tech and electric car industries. The usage of metals such as mercury is also common in the electrical industry in the production of switches and thermostats. Radioisotopes are often used for quality control and non-destructive testing, such as inspecting the quality of welds. Though the usage and disposal of radioactive material is tightly regulated, careful control must be maintained so as to avoid any type of contamination, which can add to production costs. Pollution from heavy metals, especially in the form of runoff from factories and improper disposal of punctured batteries, contribute to water supply contamination and toxicity. A study of lithium concentration in the Han River near Seoul showed a lithium concentration 6 times higher south of the city than upstream. Additionally, mercury pollution can result in direct exposure from drinking contaminated water or from consumption of fish from such waters. The EPA reports that some of the largest manufacturing-based contributions to mercury come from the combustion of coal and cement production, at 473,000 and 233,000 kilograms per year respectively.
There are also environmental concerns when it comes to the machining side of manufacturing. More environmentally friendly machines do exist and have been implemented into production. This machinery uses less fuel and electricity, produces less waste, and overall is more efficient with time. However, there are still obstacles preventing this machinery from having a truly significant impact on the industry. For example, the lobbyist groups push policies to make it harder for manufacturing to be less sustainable by cutting off funding and limiting resources and manpower. This in turn makes the industry more reliant on fossil fuels and gases. Another deterrent to creating a more environmentally friendly industry is a taboo trade-off. During the change period, more sustainable machinery competitors can come in and attract consumers with lower prices at a faster rate. This disrupts the scheduling, pricing, and overall manufacturing efficiency, which cuts into the producer's profits. In the end, manufacturers will avoid switching to more sustainable hardware because they don't want to take the hit in revenue.
To elaborate more on taboo trade-off, I will present a simple example of the concept. Let's say you're a farmer and want to switch to a more sustainable and efficient tractor to save on fuel and harvest more crops. But the new tractor will take time to get to your farm, implement it into your harvest rotation, and figure out how to use and maintain. And for a time, you won't be able to produce as many crops as you used to. but you know in the long run, it'll help forward your business and help the environment at the same time. But Farmer Richard across the street hears about your new tractor. Do you think he'll wait patiently when there's a gap in the market? No, that's the point. It would make obvious sense for any business to entice their competitors' consumers with lower prices when they know the competition can't produce as many goods as they used to. So, the question still remains, what's the solution to this?
Now we shift our discussion to the solutions to these environmental challenges that have been presented. And the solution that we are focusing on is the increased use of lean and sustainable manufacturing techniques. So what is sustainable manufacturing? That is the first question to cover. And it composes generally of three subparts. First one being minimizing environmental impact, resource and power usage, pollution, as well as the community impacts of that pollution, which can be emitted through the use of electricity as well as through the manipulation of materials. Another goal is to maximize employee safety, so the elimination of certain chemical byproducts can make the manufacturing plants much safer than they previously would be. And again, within that same line, maximizing and improving the company image as the company becomes more sustainable. Generally, the public and its consumers will appreciate it. And lastly, while the top two are very important, the most important in any industry is profit. And if the top two cannot be done in a profitable manner, it is not useful. Now, the first way would be limiting material usage. Now, this can be done, again, multiple ways. Firstly, to continue to implement additive manufacturing processes. This helps limit material use through the elimination of waste from processes such as machining. Another option could be to develop a profitable way to switch to more sustainable material sources, which these new sources would be more expensive than the previous non-sustainable ones. But if less material can be used, that would coincide with less cost. And another option which follows the point above is having a closer link between design and manufacturing teams. So if the manufacturing and design team can communicate in order to have a product that uses the least amount of material possible, this can limit cost as well as help increase sustainability. Next, we have another goal of sustainable manufacturing, which is to lower the carbon footprint. And the first way to do this would be to shift to more local production centers, away from the global economy and the global production and manufacturing network that we currently have. And this would lower the carbon footprint from shipping something across an ocean on ships and planes to shipping something 30 or 40 miles, and which the footprint from shipping manufactured items across the ocean and from plants overseas to here accounts for about 8% of global carbon emissions, which is a very high figure and something that, if can be drastically reduced, will have a significant impact. Another option is to move manufacturing centers closer to power stations. This would lower the line loss that would incur, as there'd be less length of power line required from the power plants where the power is generated, electricity is generated, which would then mean that manufacturing plants would be able to operate more efficiently. And another way is to decrease the energy cost of material handling by shifting to easier to process materials. Now, lastly, and certainly not least, would be to mitigate the cost of switching. So in order to keep something profitable, there's two options. One is increasing the price you sell at, and the other one is lowering the cost. And one way to lower the cost of switching to a sustainable manufacturing process would be to switch piecemeal. So instead of switching all production lines at once, you would switch one at a time, which would allow company to, or even an entire sector, to spread the cost of switching to a more sustainable manufacturing process over a longer period of time. And another option is, once that has been done, then there would be this new market forming of sustainable products, and through more advertising from the advertising sections of the companies, there could be an opportunity to create new markets, take over that market segment, and advertise sustainability as a quality within itself.
Thank you for watching our video projects on sustainability in manufacturing. The references for both slides and videos are being presented now, as well as the roles and responsibilities of each member. This project was assigned by Dr. Hassan Rashidi for Georgia Tech's ME 3210 course in conjunction with the first group project assignment, and its production is only for educational purposes only. Thank you.